Запись у меня вроде тоже пошла. Хорошо.
Okay, can we start?
Yeah.
Okay, good morning. Our names are Ivan Gevorkov and Alexander Osipov, and today we will hold a seminar for you on the topic crawler instruments in building geodatabases. The internet is a source of a huge amount of information, and every year it becomes more and more. While you need to get information about a single object, then the manual extraction time will be insignificant. But when you need to get data about a lot of objects, or it needs to be done regularly, the time increases many times. To solve this problem, you can write a program that automatically extracts the required information from the internet. Such a program is called a crawler. This allows you to significantly speed up the collection of a large amount of data scattered across different pages of the same site or located on different sites. Also, crawlers can collect information at certain intervals, which can be useful in various fields. But before you start writing the crawler that is necessary for solving your personal problem, you need to decide on the source of information. Since although there is absolutely everything on the internet, not everything is so perfect. The main problem of extracting information from the internet is lack of structure. Despite some facilitating moments, such as typical names of the page of site, on each side the information may be presented in different ways. Some of its part may be present or missing, or even despite the visible identical structure. The page code may be completely different. This is the main difficulty since for each case you have to write a new parser. Data extraction from web pages was divided into two large tasks. The first task involves identifying the page that contains the necessary information. The second, the data extraction itself. In other sources, the extraction process is more complex. In addition to the above task, there are also additional tasks caused by requirements of the goals. For example, the task of finding a common data structure, or the task of ensuring uniformity, which is necessary to filter out unnecessary information, or the task of combining data that connects data obtained from different sources. In addition, the task of identifying web page that contains the necessary data can be performed in completely two different ways, based on the knowledge about finding information on the internet. The first method relies on knowing the site structure that contains the necessary information and consists in the fact that when crawling the start page, all pages with the necessary information are determined by analyzing the URL. It contains the special sequence of characters that is special only for desired objects. The second method is used when you are completely unaware of finding any probability on the internet. It's based on the theory that a site of a certain topic will link to a site on the same topic. Thus, if necessary information is not on any page, then it can be on another page on the same topic. There is a continuous search for information until the necessary information is found by clicking on a random external link, if there is one, of course. Initially, the second method seems to be pointless, but in its support, I would like to show an example. Game Wikicross. The task is to obtain the needed wiki article, the essence of this game. Two players enter the same Wikipedia article, each from their own computer, and by clicking on wiki links, move from one article to another. The winner is one who is the first to get to the preconceived article. That was all theoretical information. And now I will turn this over to Ivan, who will speak about technical realization.
The best language for writing crawler is Python. One of the most popular web scraping instruments in it is the framework Scribe. It allows to access web page query data from HTML code using XPath or CSS queries. It is the fastest among competitors, which is very useful when processing a large number of pages. The difference in runtime between queries requests via Scribe and requests via another libraries was 3 times the difference when crawling all the required pages. Another commonly used instrument in web scraping development is sharing libraries requests and Beautiful Soup. With the first library, it's possible to download a web page from the internet, and with Beautiful Soup, you can further parse the HTML code. For parsing, Beautiful Soup can use LXML or HTML parser to parse the resulting code. These two tools are suitable for simple parsing cases when all information is contained in the page code and can be extracted from there. In more difficult cases, when dynamic HTML or Ajax is used, these tools will not suffice, since the page content displayed in the browser will not match the extracted code. To extract hidden information in addition to the previous libraries, you must use additional ones, such as Selenium. They allow to compose a site portrait, how it is displayed in the browser, and simulate user actions in order to update the site and get initially hidden information. And our prototype. The order of information extraction can be structured as follows. First, all eternal links on the main page are iterated over. All of them that do not contain planes are eliminated and suitable ones are written to a file. Fortunately, as a source of information we choose, site airlines inform. As you can see, one of the advantages of this site is that page which contain information about aircraft have a specific URL, initial aircraft, and after that aircraft name. If duplicate links are encountered during the selection process, they are also eliminated. After receiving all the links, the second crawler starts work. It sequentially iterates over all links from the file and collects data from the table on each page. We can say that these crawlers work with almost structured information. Its target is only data from one table, which is on every page. However, the content of the table itself may differ. It may contain or conversely be missing some fields that are present in the tables on other pages. Also, the table can contain several aircraft models. For this, a data template was created that contains all possible fields in all tables. As the next table is parsed, the found values are entered into this structure, other fields remain empty. A single template greatly facilitates further work with data. And this is an example of information on a website and in our file after parse. Actually, this is all what we wanted to tell you today. If you have any questions, you can touch them now.
Thank you so much, colleagues, for interesting presentation and for interesting experience about project working. But as for me, I have one question about this experience. Why did you prefer Python language and Python library?
Well, because we chose them because in Python language, much more instruments for working with these problems. And also in Python, a lot of libraries which can help in some extra works with data.
Okay, yeah, thank you. Any question? We can use Russian or English. There are no foreign colleagues today. The major reason, early time, as I understand. Okay, but I think that we will have new colleagues. There are the seminars for the new seminars. There are no questions. Okay, thank you. Colleagues, I'll use Russian because we have only Russian colleagues. На самом деле, спасибо за презентацию. Я так понимаю, вопросов у нас действительно больше нету. Да и присоединиться, я думаю, 20 минут хватило бы, чтобы еще кто-то присоединился. Запись мы, наверное, останавливаем. Соответственно, позже выложим для всех желающих, может, потом вопросы появятся.